Hello! In this video, we're going to review how to solve higher degree polynomials when you can't factor or use the quadratic formula because we're going to be dealing with polynomials that aren't quadratic equations. So for the first example, they want you to show that x minus 2 is a factor of p of x. The easiest way to do this is to use the remainder theorem. And in order to use the remainder theorem, if you are checking to see if x minus 2 is a factor, then you set it equal to 0 and solve for what your potential 0 may be. So now we're going to take the equation and put it in the calculator as y equals x cubed minus 3x squared minus 10x plus 24. And we're going to look at the table specifically at x is equal to 2. Now, if we get a 0, it's going to be a factor. And if we don't get a 0, that means when you divide by x minus 2, you get a remainder. So it is not a factor. So I already plugged it in my calculator, the equation under y equals. And now I'm going to go to the table to see if it was a factor. Now, because we're dividing by x minus 2, or checking to see if x minus 2 is a factor, we're going to go to positive 2. And at positive 2, I get y equals 0. So this tells me that there is no remainder. Oops. And therefore, x minus 2 is a factor. Now, it didn't ask you to explain, so all you had to do was show the math to show that it actually is a factor and that there's no remainder. For the next one, they want you to find the quotient. You can either do this by long division, you can do this by the reverse tabular method or the reverse box method, how you can call it, or you can do synthetic division. In this case, synthetic division is probably your fastest bet. So as a review of synthetic division, you're going to take the coefficients and write them out. My coefficient of x cubed is 1. The next one is negative 3, negative 10, and 24. Now, if you're dividing by x minus 2, just like in part A, we're going to use a positive 2 on the outside. In synthetic division, you bring the first one down, and then you multiply the 2 on the outside to get the next one under the negative 3. So 2 times 1 is 2. And then you add. Negative 3 plus 2 is negative 1. 2 times negative 1 gives me negative 2. Add. Negative 10 plus negative 2 is negative 12. Go back to multiplying. 2 times negative 12 is negative 24. And when you add it, you get 0. Your last term is your remainder, which makes sense because we already know that we should have no remainder here. So I have my remainder, the constant, the x to the first, and the x squared. That means when I input my variables back in, I'm going to get 1x squared minus 1x to the first, not plus, we have a minus 12 with a 0 remainder. You can also write the quotient as x squared minus x minus 12. Now they want you to find the next two factors. So I'm going to take my quotient from the last example, which was x squared minus x minus 12, and I can factor this further now with the AM method. and I'm going to get two numbers that multiply negative 12 and add to negative 1. That's going to be negative 4 and positive 3. For the next part, they want you to write p of x as a product of three linear factors. Well, we already know that our first factor from part A was x minus 2. And then we factored the quotient we got from dividing to get x minus 4 and x plus 3. And of course, it says write p of x, so I'm going to have p of x equals. That way it's an equation. Now I can even go further and solve this by setting up a t-chart. So I'm going to take my factors, I'm going to set it equal to 0. Now I'm going to get that x is equal to 2, 4, and negative 3. Now that tells me that my x-intercepts are going to be at 2, 4, and negative 3. If I wanted to write them as coordinates, remember which go x comma y, your x-intercepts are your solutions, comma, 0 as your y-coordinate. So just by knowing one factor, we can divide to get a quotient, factor the quotient to get the other factors to help us solve for all of the solutions to the original problem. Let's try another one. So for the first one here, they're asking you to verify that p of 9 is equal to 0. The easiest way to do this is in your calculator, plug in y equals x cubed minus 8x squared minus 29x plus 180. And then go to your table and at x is equal to 9, we should be getting 0. So I typed the equation into my calculator, and now I'm going to go to the table. And I'm going to scroll down to 9, which in fact gives me 0. So I verified it. When I plugged in 9, it gave me 0. The other way is substituting 9 in by hand and evaluating it that way. Now, if x equals 9 is your 0, that means the factor is x minus 9, the opposite. And if something is a factor, then you can divide by it. So again, fastest way to divide is synthetic division. I'm going to take my coefficients of p of x, which is 1x cubed minus 8x squared minus 29x plus 180. And it's because we're dividing by x minus, we're going to put a positive 9 on the outside. Bring down the 1, and 9 times 1 is going to give you 9. When you add negative 8 plus 9, you get a positive 1. And we're going to multiply again. 9 times 1 is 9 again. And we add negative 29 plus 9 is going to give me negative 20. When we multiply 9 times negative 20, we get negative 180, which when we add, we get 0. That makes sense because we know that x minus 9 is a factor, so we should be getting a 0 remainder. From there, we have your remainder, the constant, the x to the first, and the x squared. That means when I write out my answer, I am going to have x squared plus x minus 20 as my quotient. Now I can keep factoring this polynomial by factoring my quotient that I got when dividing. So to find the other two factors, I take my quotient and I factor with the AM method. My two numbers that multiply to negative 20 and add to 1 are going to be positive 5 and negative 4. To write it as a product of three linear factors, in part A, we found out that originally x minus 9 was a factor. When we divided by x minus 9, I had two new factors when I got the quotient and factored again, which was x plus 5 and x minus 4. Now, if you want to find the solutions, take your factors, set it equal to 0, and do a t-chart. You're going to get x is equal to 9, x is equal to negative 5, and x is equal to positive 4. So that means I can use my solutions to find my intercepts. I'm going to have 9, 0 as one coordinate, negative 5, 0 as another, and 4, 0 as my third x-intercept on the graph. And keep in mind that this couldn't be done by factoring originally. If we go back up to the top, this couldn't be factored by grouping. So since you can't factor it, your only alternative is to figure out what one factor is, like in part A, dividing by the factor, and then trying to factor the quotient like we did here. Now, tomorrow in class, what we're going to go over is how to determine what the original factor is. In both of these questions, I gave you the factor. Tomorrow, we're going to be looking at the graph to find a factor and then helping us find the factor to help us divide and ultimately find all of the solutions. And that's all for this video.